Today's session is about Northwest Corner Rule. It is one of the methods to solve transportation problems, which is seen in operation research. Northwest Corner Rule is a method to find a feasible solution to a transportation problem. Transportation problem is a special type of linear programming problem, LPP, in which goods are transported from one set of sources to another set of destinations based on the supply and demand of the origins and destination, respectively, such that the total cost of transportation is minimized. Transportation problems are of two types. Balanced transportation problem where both supply and demand are equal. Unbalanced transportation problem where supply and demand are not equal. In this case, it has been converted into balance format by adding a dummy column or row. If demand is more than supply, then add a dummy row with cost 0 and supply equal to demand minus supply. If demand is less than supply, then add a dummy column with cost 0 and demand equal to supply minus demand. Approach. Step 1. Check whether supply and demand are balanced. If unbalanced, demand is not equal to supply, that is, if demand is more than supply, then add a dummy row with cost 0 and supply equal to demand minus supply. If demand is less than supply, then add a dummy column with cost 0 and demand equal to supply minus demand. Step 2. Select the upper left, northwest, cell of transportation matrix and assign minimum value of supply or demand. Step 3. Subtract the above minimum value from OI and D of the corresponding row and column. Here, we may get three possibilities, as given below. 1. Supply is equal to 0, then strike that row and move down to next cell. 2. Demand is equal to 0, then strike that column and move right to next cell. 3. Supply is equal to demand is equal to 0, then strike both row and column and move diagonally to next cell. Step 4. Repeat these steps until all the supply and demand values are 0. Step 5. Calculate the total minimum transportation cost using the quantities and allocated values. Let us understand this clearly with examples. First, we shall understand how to solve balanced transportation problem. Example: obtain the feasible solution of the given transportation problem using Northwest Corner Rule. Transportation problems are given in such tabular form. Here origin and destination are given along with supply and demand. Our objective is to transport the quantities from origin to destination in the way to reduce the transportation cost. Solution: this is the table. Step 1. Check whether supply and demand are balanced. So here we must calculate total supply by adding these 5 plus 8 plus 7 plus 14, which comes to 34. Similarly, we must calculate total demand by adding these 7 plus 9 plus 18, which again is 34. Hence here we see balance of supply and demand. Step 2. This is Northwest Corner Rule. Here this 2 is in northwest. Hence we will start from here. Here supply is 5 and demand is 7, which is less. 5 is less, so 5 is minimum value assigned. Here 5 minus 5 becomes 0. Here 7 minus 5 is 2. Since supply becomes 0 here, this row is cancelled. Now we move down, between 8 and 2. 2 is less, so minimum value assigned is 2. Here 8 minus 2 is 6 and here 2 minus 2 is 0. Since demand becomes 0, this column is cancelled. Now we move to right, between 6 and 9. 6 is less, so minimum value is 6. 6 minus 6 is 0. 9 minus 6 is 3. Supply becomes 0, row is cancelled. Now we move down, here 7, here 3, minimum value is 3. 7 minus 3 is 4 and 3 minus 3 is 0. Demand is 0, so column is cancelled. Now we move to right, here 4 and here 18, minimum value is 4. 4 minus 4 is 0 and 18 minus 4 is 14. Supply is 0, so row is cancelled. We move down, Here we see 14 both in supply and demand, so minimum value assigned is 14. 14 minus 14 is 0. Thus we got both supply and demand become 0. Next step is to calculate minimum feasible transportation cost. These are quantities and these are allocated values. Calculate the total minimum cost of transportation by adding the product of the above values. Total minimum cost is equal to 2 times 5 plus 3 times 2 plus 3 times 6 plus 4 times 3 plus 7 times 4 plus 2 times 14 equals 102 rupees. Here, number of allocated cells is equal to m plus n minus 1, where m and n are source and destination. Number of allocated cell S is 6, m is equal to 4 and n is equal to 3, so 4 plus 3 minus 1 is equal to 6. This solution is non-degenerate. A solution is said to be non-degenerate if allocated cell is equal to m plus n minus 1 and allocated cells are in independent position, they don't follow closed path. Let us understand how to solve unbalanced transportation problem. Example: obtain the initial feasible solution of the given transportation problem by using northwest corner rule. Solution. This is the table. First, 1. Check for balance of supply and demand. Total supply is equal to 15 plus 25 plus 42 plus 35 is equal to 117. Total demand is equal to 30 plus 20 plus 15 plus 10 plus 20 is equal to 95. Demand is not equal to supply. Here, demand is less than supply, so add a dummy column with cost 0 and demand equal to supply minus demand. Demand is equal to 117 minus 95 is equal to 22. Step 2. This is northwest corner rule. Here this 5 is in northwest. Hence we will start from here. Here supply is 15 and demand is 30, which is less. 15 is less, so 15 is minimum value assigned. Here 15 minus 15 becomes 0. Here 30 minus 15 is 15. Since supply becomes 0 here, this row is cancelled. Now we move down, between 25 and 15. 15 is less, so minimum value assigned is 15. Here 15 minus 15 is 0 and here 25 minus 15 is 10. Since demand becomes 0, this column is cancelled. Now we move to right, between 10 and 20, 10 is less so minimum value is 10, 10 minus 10 is 0, 20 minus 10 is 10. Supply becomes 0, row is cancelled. Now we move down, here 42, here 10, minimum value is 10. 10 minus 10 is 0 and 42 minus 10 is 32. Demand is 0, so column is cancelled. Now we move to right, here 32 and here 15. Minimum value is 15. 15 minus 15 is 0 and 32 minus 15 is 17. Demand is 0, so column is cancelled. Now we move right, here 17 and here 10, so minimum value is 10. 10 minus 10 is 0 and 17 minus 10 is 7. Demand is 0, so column is cancelled. Again we move right, 7 and 20. 7 is less and so minimum value. 7 minus 7 is 0 and 20 minus 7 is 13. Here supply is 0, so row is cancelled. Now we move down, 35 and 13. 13 is minimum value assigned. 13 minus 13 is 0 and 35 minus 13 is 22. Demand is 0, so column is cancelled. We move right, here we see 22 both in supply and demand, so minimum value assigned is 22. 22 minus 22 is 0. Thus we got both supply and demand become 0. Next step is to calculate minimum feasible transportation cost. These are quantities and these are allocated values. Calculate the total minimum cost of transportation by adding the product of the above values. total minimum transportation cost is equal to 5 times 15 plus 3 times 15 plus 9 times 10 plus 2 times 10 plus 7x 15 plus 6 times 10 plus 5 times 7 plus 9 times 13 plus 0 times 22 is equal to 547 rupees. Here, the number of allocated cell S is 9, M is equal to 4 and N is equal to 6, so 4 plus 6 minus 1 is equal to 9, where M and N are source and destination. This solution is non-degenerate. A solution is said to be non-degenerate if allocated cell is equal to M plus N minus 1 and allocated cells are in independent position, that is, they don't follow closed path.